This is section 6.4, inverse functions, day number 2. What we're looking at today is trying to figure out if a function has an inverse function, and we're going to try something first to see if it's going to work. So, an inverse function exists if the original function passes what's called the horizontal line test. We're going to look at a simple example first, like an even-powered equation like x squared. We know x squared is a parabola, two legs both facing the same direction. If I were to try the horizontal line test on this, I would see that that horizontal line passes through the curve more than one time. If that happens, then it fails the horizontal line test. All even-powered equations will fail the horizontal line test. What about the odd-powered functions, though? Some of them will pass. If you have the basic y equals x to the third, the cubic graph, and try to plot some points, you will get this picture right here. If I try my horizontal line test any place on this curve, it only passes through that curve one time. So yes, this is a function. It will also then have an inverse function. But if I look at this odd-powered graph that has multiple curves in it, you could tell, remember, it's odd-powered because the legs are facing opposite direction. If I try my horizontal line test now, it passes through this curve 3 times, hence it fails the horizontal line test. Here's another example on the end of an even-powered graph, legs facing the same direction. I try my horizontal test, it passes through 4 times, it fails the horizontal test, so it does not have an inverse function that exists. Let's look at the equation y equals x squared. This is a parabola. We know that the parabola fails the horizontal line test. But what if we give it a particular parameter? If we let y equals x squared, but we're going to restrict the domain to be just x positive, so it's as if I'm taking this entire curve of the parabola, but I'm only going to look at half of it. So where x is positive, that's the dividing line. So all of this is then removed from the graph. It's going to leave me with this picture here. It's just half the parabola right-hand leg. So now if I try my horizontal test, it passes, and I can then find the inverse function to go with that. Now remember our inverse rules. You switch the letters and then resolve for y. So I start with y equals x squared. I swap my letters. I get x equals y squared, and then resolve to get y by itself. Square root on both sides, and I'm left with y equals the square root of x. The square root of x is then the inverse function, and I can write the inverse function notation right down here. F inverse of x equals the square root of x. Now this is the one situation where we are not going to put plus and minus because we only want it to be the positive half to this particular curve. If we included the bottom, the plus and minus to go with it, then you would get the other half to the parabola. And if you notice, that would then fail your vertical line test. So I do not include the negative piece to the square root. So I'm going to just erase that for you. And this is the picture of your square root graph. Now, if I were to look at the square root, or the x to the second graph, y equals x to the second, and plot some ordered pairs, then do the swap with ordered pairs like we looked at the other day. A couple samples. If I let x equal 0, 0 squared, still 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. If I now swap letters and swap numbers, 0, 0 becomes still 0, 0. 1, 1 still becomes 1, 1. 2, 4 now becomes 4, 2. And if you notice, those points plotted on this graph are highlighted in the bold dots. So those would be the first 3 dots that we use in our parent function for the square root graph. And that's what we looked at the other day. The 3 ordered pair go-to points for the square root function, 0, 0, 1, 1, and 4, 2. After I left the Peace Corps, I worked as a recruiter in a Peace Corps recruiting office. And the office I was assigned to was in Los Angeles. All right, so here's two examples. We want to try to see if there is an inverse, and if so, can you find it? We've looked at the x to the third graph. We know that those ordered pairs are -1, -1, 0, 0, 1, 1, and that particular picture looks like this, low to high. If we try our horizontal line test, I know that there should be only one time that it crosses through the graph, so yes, there is an inverse to this, and I need to find that. The steps. First we swap letters. X equals y to the third, and then I resolve for y. Do the cube root on both sides. Cube root and the cube will cancel, and I get y is equal to the cube root of x. So, something good to know, y equals x to the third, and y equals cube root of x. Those are inverse functions of each other. This particular graph, which we've looked at, is the graph that then goes side to side on your picture. And yes, if you drop any horizontal line, or excuse me, any vertical line, it passes through just once. So this is an inverse, and we can upgrade our notation with our F inverse notation, cube root of x. This last one, f of x equals 3x to the fifth minus 2. Odd functions, as long as there are no other x's in the middle, odd functions always have that snaky S-curve standing straight up. And yes, it passes the horizontal line test. So yes, I can find an inverse, and then I can exchange my letters and solve for that. We'll start with the original. Y equals 3x to the fifth minus 2. Swap. X equals 3y to the fifth minus 2. X plus 2 equals 3y to the fifth. Divide your 3 out next. X plus 2 over 3 equals y to the fifth. And now I need to get that raised to the fifth out of there. I'm going to do the inverse, which I could write it as raised to the 1/5, or you could do it as the fifth root of. Remember, those are the same thing. So instead of 1/5, I'm actually going to write it that way, fifth root of, and then big fifth root of on this side. Y equals the fifth root of x plus 2 over 3. There's your inverse function. Okay, word problems. Whenever you look at word problems that ask you for an inverse function, do not swap letters. Remember, that's usually our process. We swap the letters and then resolve for y. In a word problem, you do not swap the letters. The only thing you do is just resolve for the new variable. So here's a sample. The population of a town is given by the function p equals 16,500 times t raised to the 0.15. Find the inverse model that gives years as a function of population, where t is the number of years since 1998. Okay, do not swap letters, just resolve to get t by itself. P equals 16,500 times t raised to the 0.15. Divide out 16,500 equals t raised to the 0.15. Now I need to get rid of that raised to the 0.15. I'm going to up it again to the 1 over 0.15. I'm going to do that on the other side as well. 1 over 0.15. Cancel, cancel. T equals P over 16,500. Now it's going to be raised to the 1 over 0.15. Now if you remember the rule, it's probably not good to leave a decimal inside of a fraction. So actually punch that in. How much is 1 divided by 0.15? We're going to write that as a decimal instead. 6.67. Now I don't have a decimal inside of a fraction. I just have a regular decimal number. So this is the inverse function. This is the way they write it here. It gives you years as a function of population. So it's talking about t. T is time. It's giving you a population of t, or a function of t, in relation to your population. The next one we're going to do is actually from your homework. This is question number 49 in your book. So if you want to grab your book real quick, work this one right now, and then we won't have to do it in class. This is on page 444 in your book. The maximum hull speed of a boat with displacement hull can be approximated by V equals 1.34 times the square root of L. L is the length of the boat's water line. Find the inverse of the model. Then find the water line length needed to achieve a maximum speed of 7.5. All right, so first we need an inverse model. Do not swap letters, just resolve. V over 1.34 equals square root of L. How do you get rid of your square root? Square both sides. Square, square. Length equals V over 1.34 squared. There's step number one. You wrote the inverse model. Now we're supposed to figure out what the length is going to be if we have a speed of 7.5 knots. So now you just use your model, and in place of V for your velocity, put in 7.5. 7.5 over 1.34, that quantity squared, gives me length. Punch that in your calculator, and hopefully you get approximately, we'll round this, approximately 31.3 feet for your hull length. Okay, there you go with section, page 444, question number 49 from your homework. You can now go to Skyward and do your online quiz for section 6.4, part 2. Make sure you look for that in Skyward. 6.4, part 2, your quiz will be open until midnight.